Don't say your question.
That's me.
All right, so today is about distance on a coordinate plane. So sometimes finding distance between two coordinates is easy. It's a straight line on those coordinates. You can just count. Like the distance on this first one is 1, 2, 3. Okay? So sometimes you can look at it, just count, and you've got the distance. Sometimes it's going to be a diagonal line. And we can't just estimate it by counting, oh, like this looks like it's half of a square, this looks like this is a third of a square. It doesn't work like that. So we can use the Pythagorean theorem to find that distance. And what does that look like? What we were talking about?
The C.
The hypotenuse. All right, so to find a diagonal distance on a coordinate plane, we create our own right triangle. And then we can use the Pythagorean theorem.
How do you say it?
Pythagorean.
Pythagorean. I was saying
Pythagorean.
All right, so if you look up here at graph B, what you're going to end up doing is just tracing to make a right triangle. So you can start at the bottom one or the top one. It doesn't matter. But you're just going to either go down or up. So like this one, I would go down, and then I would go over. And that's going to make that right triangle, and then you can count the units. So like the tall part is 1, 2, 3. The bottom part is 1, 2, 3, 4, and then you can use 3 and 4 to find that hypotenuse. Okay, so the diagonal distance is called the hypotenuse, which is what we just said, and we said that that is C. So we're going to use that A squared plus B squared plus C squared again. Yeah.
When? Like, don't ask when everything's in mind. No. Okay. Don't have that. Then I'll ask that later.
All right. So moving on down here to problems, it says use the Pythagorean theorem to find the distance between points A and B on each graph and round your answer to the nearest 10. So what does that mean to round your answer to the nearest 10? So what? But what does tens mean?
the first place behind the decimal.
Like the first place, like 1 decimal place. All right, so let's look at number 1 together. So I'm going to draw a diagonal line between A and B. Now, if Trevor wants to start at B and draw down and over to make his triangle, but Carly wants to start at A and go up and over to make her triangle, it does not matter, okay? Whatever makes the most sense to you. I like my triangles to be down, so I'm going to start at B. So I'm going to go to B, and then I'm going to go over to A. So I'm just connecting on the lines. Now, once I do that, I can count the units on the graph. So looking up here, this straight line, this vertical line, it's 1, 2, 3, 4, 5. So that's 5. And then I'm going to count over here on the side. 1, 2, 3, 4. So this is 4. And then I'm going to use the Pythagorean theorem to find that diagonal C. So it doesn't matter which one's A and B. So A squared plus B squared equals C squared. So that's 16 plus 25, that's 30, so 31 or
41.
41. 16 plus 25. So that's 41 equals P squared. And then what should I do to find the diagonal now? Square root it. So I'm going to square root that 41 on my calculator, and I get 6.4. So my hypotenuse is 6.4. Huh? You look at the decimal place, it says 10th place, so when you take the square root of 41, it says 6.40, so 0 doesn't round 4 up, so it's just 6.4. All right, let's look at number 2. So I'm going to connect A and B, and then I'm going to trace my line. So I'm going to go down and then over. So that'll make me a right triangle there. And then I'll count. So 1, 2, 3, 4, 5, 6, 7. So that's 7. 1, 2, so 2. So I'm finding the C, so there's my A and my B. So 7 squared plus 2 squared equals C squared. So that's 49 plus 4, which is 53, equals C squared. And then I'll square root that. And we're only going around to one decimal place, so 7.3. All right, you all try number 3.
Something like this. Not making that WP. I was hoping you could do something else.
Okay. So I'm gonna connect my A to B. I'm gonna trace my lines there. My lines are straight. Okay. All right. So 1, 2, 3, 4, 5, 6, 7, 8. So 8. And then 1, 2, 3, 4, 5, 6, 7, 8 again. That's what I got. All right. So 8, 8. So 8 squared plus 8 squared equals that C squared. So 64 plus 128 equals C squared. Square root 128, we get 11.3. All right, moving on to the back. The difference from 4, 5, and 6, from 1, 2, and 3 is that you have to graph your A and B first. So they just give you what A and B are. So -6, 1 and -4, 5, and then you're going to find the distance between the two using the Pythagorean theorem. So use the graph of Pythagorean theorem to find the distance between the points. So I think I'm going to label mine A and B. So -6, 1, when you graph coordinate points are x, y. So I'm going to graph the x-axis and then the y-axis. So -6, I'll go left, -6, and then up to 1, and that's going to be my A. And then B is -4, 5. So I'll go left to -4, up to 5. And then after that, it's just like the other. So I'll connect them. This is a little sweet. And then follow my line there. So 1, 2, 3, 4. 1, 2. So I'm going to find my C. So A squared plus B squared equals C squared. So that's 4 plus 16, that's 20 equals C squared. I'll square root my 20, and I get 4.5. All right, you all do number 5. Straight line, straight line. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you all got 4 and 11?
Yeah.
Alright, so 4 squared plus 11 squared equals c squared. That's 121 plus 2, so that's 136 equals c squared. Square root 136. And we get 11.7.
Are these all?
137.
I got 137.
Oh, okay, sorry, 137. Alright, here's the thing though. Let's say that Simi's was doing his and he got 10. 10.6. How could you reason with Sims that he did not get the correct answer without giving him your calculator? Alright, Frankie. Alright, Santa.
Because there's a 11 is the bigger side and C showing the bigger.
Yes. Yes.
Good job.
So if your C length is smaller than one of your side lengths, then you did something wrong. So when you're doing Pythagorean theorem, that C should always be the longest. All right, we're gonna skip number 6 and just move on to redundant. Okay, number 7. Find the perimeter of the trapezoid. Now, how do you find perimeter of any figure? Add up all the sides. Now, I know a lot of these sides. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6, 7, 8. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I don't know that one. We don't know that. We have no idea. Does anybody have any ideas on what we might be able to do, Trevor? Okay. All right, so I could cut this triangle off. Now, what would the length of this be? 8. And what would the length of this be? 6. Well, we gotta count 1, 2, 3, 4, 5, 6. So this will be 6. And then I can find that C. I can find that diagonal. So this is kind of like a composite figure, which I'm getting ready to start with the Math 7 kids. But a composite figure is 2 shapes put together. So sometimes you have to cut a piece off to find the missing side and then put them back together. So I'm going to work on this triangle here. So I'm going to do 8 squared plus 6 squared equals c squared. That's 64 plus 36, so that's 100 equals c squared. So my c is 10. All right, and then now to find the perimeter, I'm going to add up all 4 of the sides. So 6, 8, 12, and 10. So 8 plus 12 is 20. 20 plus 10 is 30. 30 plus 6 is 36. All right, let's look at number 8 here. If you're struggling with number 8, I'm going to let you do it on your own, but I'm going to give you a hint here. All right, so I want you all to try to find number 8. Okay. I thought you were looking at the board. No. Shh.
Right here, Samuel. Hey.
Yeah, don't call me that.
It's Samuel, it's Samuel. All right, Samuel, look. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this whole length is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That whole length is 9. This triangle, 1, 2, 3, 4. 1, 2, 3. I'm gonna find that C. If you look up here, this one's also 4 and 3. So whenever you find one of them, it's the same as the other one. So 3 squared plus 4 squared equals C squared. So that's 25 equals C squared. So 5 is my C. And then this whole length was 9. This whole length was 9. This length was 5. This length was 5. So 5 plus 5 is 10. 9 plus 9 is 18. And 10 plus 18 is 28. All right, moving on to the last question down here. It says, in the graph below, point A represents Ashley's house, point B represents Bridget's house, and point C represents Carly's house. Each unit on the graph represents 2 miles. So, like, if I count on there and I count 5 squares, how many miles is that?
10.
10. If I count 4 squares, that's 8 miles. As it. Okay, so it says to the nearest 10. So 1 decimal, how many miles is Ashley's house from Bridget's house? So from A to B. They want to know the length from A to B. So find the right audience, Frankie. Go get 5 and 11.
Yeah.
Okay.
Oh, shoot.
All right, so when I found the hypotenuse, I got 12.1, since I rounded near twin, 12.08. 8 rounds to 0 to 1. Now, that's not the answer, because they told us that each box represents 2 miles. So, Brecken, what's the answer?
24.2.
So, I'm going to multiply this by 2 miles, and that's going to give me 24.2 miles. My answer. All right, try B. So how many miles is Ashley's house to Carly's house? All right, Brecken, I'm not ready yet.
Oh, yeah, look, my SP. Let me just get it.
I did not do this, I was special everybody. You were singing the cigar special band. Yes, because I still.
All right. So from Ashley to Carly.
That was me.
All right. So this is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you want me to do it at 10?
Yeah.
All right. So 2 squared plus 10 squared equals C squared. So that's 104. And then the square root of 104 is 10.19. So that rounds to 10.2. And I'll have to multiply that by 2 to get 20.4 miles.
All right, so it says, whose house does Ashley live the closest to? Carly, and by how many miles?
3.8 is 24.2 minus 20.4 is 3.8 miles. Right.
Homework.